Hello everyone, welcome to the next lecture. In this lecture, we shall see problems on logarithms. Let us check the concepts and formula. A logarithm is the inverse operation of exponentiation. Exponentiation means raising some number to a certain power and finding out the value. Here, we have to find out to what power must a given base be raised to produce a specific number. That is, for example, if there is a base a and we can raise to power m so that the value will become x. So here to find out the value of m, we can take log of x to the base a. Okay, that is, if a is a positive real number other than 1, then a power m is equal to x. Then we can write m is equal to log x to the base a, and we say that the value of log x to the base a is m. Okay, so if there is any given number, for example, p power some unknown x is equal to q. Therefore, you can find out x is equal to log of q to the base p. This is the fundamental definition of logarithm. Next, we shall see some examples. 10 cube is equal to 1000. Therefore, we can say log 1000 to the base 10 is equal to 3. So, to find out the power, we can use logarithm of 1000 to the base 10, which will be equal to 3. That is the power. Next, 3 power 4 is equal to 81. Therefore, log 81 to the base 3 is equal to the exponent 4. Similarly, next one is log 1 by 8 to the base 2 is equal to minus 3. And finally, log 0.1 to the base 0.1 is equal to 2. Okay. Next, we shall see the properties of logarithm. Log xy to the base a can be written as log x to base a plus log y to base a. When the base is common, you can split the product of two numbers into separate logs, that is log x plus log y. Similarly, log xy is equal to log x minus log y. Here the base remains same throughout. Next, logarithm of any number to the base of same value is equal to 1. And always logarithm of 1 to any base is equal to 0. And then when logarithm of x raised to power p to the base a is given, we can write this as, we can take this p to the left hand side, that is p star, that is p into logarithm of x to the base a. Similarly, we can write logarithm of x to the base a is equal to 1 by logarithm of a to the base x. So here we are reversing the terms. Next, we can write logarithm of x to base a as logarithm of x to base b divided by logarithm of a to base b. Here we can convert this to fraction by converting with a common base. Next one, a raised to logarithm of x to base a is equal to x. So if logarithm is present in the power term, then you can directly take the argument value, that is the number inside the bracket. So finally the answer will be x. Last one, x raised to log of y to base a can be written as y raised to log of x to base a. So here the base of the logarithm remains same, the exponent and the base changes. Here the values x and y will get interchanged. So if you see in these properties, almost all the properties are useful to solve the problems. So let us revise once again. Okay. Next, we shall see the type of logarithms. The first one is common logarithm, that is logarithms to the base 10 are known as common logarithms. Example, log 10 to the base 10 is 1, log 1000 to the base 10 is equal to 3. So this is nothing but log 10 cube to the base 10. So this can be written as 3 into log 10 to the base 10, which is again 3 into 1, which is 3. Okay. Note that when base is not mentioned, by default it is taken as 10. That is for common logarithms. And the next one is natural logarithms. That is logarithms to the base e are known as natural logarithms. The value of e is approximately 2.718. This is the exponential. Okay. And usually the natural logarithms are written as ln, that is ln. Here ln of e to the base e is equal to 1. Similarly, ln of e square to the base e is 2. It is not 3, it is 2 here. Okay. Next, let us see the parts of the logarithm. The logarithm of a number contains two parts, namely characteristic and mantissa. That is, log of x to the base 10 is equal to characteristic plus mantissa. This is commonly applied for log to the base 10. Okay. characteristic is the integral part of the logarithm of number and mantissa is the decimal part of the logarithm. Okay. For example, log 120 to the base 10 is equal to approximately 2.079, where the characteristic is 2 and the mantissa is 0.079. Here we will be focusing more on the characteristic part than the mantissa part. Okay. So to find out the characteristic, whenever the given number is greater than 1, then the characteristic is number of digits before the decimal minus 1. For example, in the first case, the number is 348.25. The number of digits before the decimal is 3. Therefore, the characteristic is 3 minus 1 is equal to 2. Similarly, for the next one, the number of digits before the decimal is 2. Therefore, the characteristic is 2 minus 1 is equal to 1. Similarly, for the last one, it is 0. Next, when the number is less than 1, like decimal shown here, then the characteristic is given by number of zeros after the decimal plus 1. That is, number of zeros after the decimal here is 0. Therefore, 0 plus 1 is equal to 1, and it is denoted by a bar above it. Okay. Next, in this case, the number of zeros after the decimal is 0. Therefore, the characteristic of this one is 1 plus 1 is equal to 2. So, it will have a bar on it. Similarly, for the next one, the characteristic is 3 bar. Okay. Okay. We shall solve few problems in the next lecture. Thanks for watching. I will see you in the next video.